welcome to the Absolute RecAP Biology Edition. I'm your host, Melanie Kingett, and I'll be your guide to scoring a 5. Here at the Absolute RecAP, we aim to maximize your understanding and minimize your need for memorization. Each episode will review content, skills, and test-taking tips to help you succeed in May. Your recap starts now. Hi, and welcome to the Absolute RecAP Biology Edition. Today's episode will recap surface area to volume ratios. Let's zoom out. We're in Unit 2, Cell Structure and Function, Topic 2.3, Cell Size. Our big idea is energy. Okay, so why are there no elephant-sized amoebas? Today's podcast will attempt to answer this question. The College Board has 2 primary learning objectives for this topic. Students should be able to, number 1, explain the effect of surface area to volume ratio on the exchange of materials between cells or organisms and the environment. Meaning, you should be prepared to discuss microscopic and macroscopic examples. Second, students should be able to explain how specialized structures and strategies are used for efficient exchange of molecules to their environment. Let's zoom in. First, some definitions. Surface area. Capital S, capital A. A measurement of how much exposed substance an object has. This is 2D space and will have a number expressed in units squared. Volume, capital V, is a measurement of the amount of 3D space an object has. This number can be expressed in units cubed, but has other units specific to the state of matter of solid, liquid, or gas. You're probably familiar with milliliters as an example. As a point of comparison, you go to Starbucks. You order a venti pumpkin spice latte because you just can't get enough. The exterior portion of the cup that your hand is touching is the surface area. The latte, in liquid, occupies the 3D space in the cup and represents volume. Because the cup has height and a radius, you could get fancy and calculate the surface area to volume ratio of your latte. Actually, here's an Absolute RecAP challenge. Students, it's time to practice. Go out. Calculate the surface area to volume ratio of the tall, grande, and venti Starbucks cup. Make a claim about which cup has the least amount of heat loss to the environment. Provide evidence for your claim with calculations, and justify your reasoning. Send your responses to TheApsoluteRecap@gmail.com by April 15th for a chance to win a personalized exam prep podcast. Remember, the 2020 test is on May 11th. Okay, so about those calculations I mentioned. We can't compare a ratio without figuring out our numerator, or top fraction number, and the denominator, or bottom fraction number, individually. The equations will be provided for you on the exam math sheet on the day of the test, but it is still your role to apply them correctly. Here's a rundown. Capital V is volume. Lowercase v is velocity, which is physics, and a different podcast. The pi symbol, pi, looks like a cursive R and is italicized. This is often truncated to 3.14, but it is always more accurate to use the pi symbol in your calculator. Lowercase r is radius, or half the distance across a circle. L is length, H, height, W, width, and S, the length of a cube's side. You will also see superscripts, or numbers above the variables that tell you to square or cube the value. Squaring is represented as a 2, and it means to multiply a number by itself. Cubing is represented by a 3, and is to multiply a number by itself twice. For example, 3 squared would be 3 times 3, or 9. 3 cubed would be 3 times 3 times 3, which would be 27. All this math. But what's the main idea? I thought this was about cells, not cubes or spheres. Here it is. Cells function best with the greatest surface area to volume ratio. All of the action or metabolism of the cell is happening within the volume. And so, they want many peripheral opportunities to take in nutrients and get rid of waste. Imagine you are going to a concert at a big venue downtown. When you arrive, you park your car a million miles away because there are so many people. You enter the venue and you find your seat. Their concert is amazing and everyone stays until the encore performance. But then, the mad rush occurs. All 50,000 people want to leave the venue at the same time. There are only 5 parking lot exits open, and so you wait. For hours. That is a lot of volume to leave through such a limited amount of surface. Very inefficient. Imagine how much faster people could leave if they could drive over curbs and barriers. This is like the cell. The people are the proteins, carbs, gases, wastes that need to cross the phospholipid membrane. And while the membrane does have a say in what can cross when, for a future episode on transport, the greatest surface area per volume of space will always accomplish the task best. A few more examples. You are cold and shivering, and the hair on your arm stands up on end. Why? The hair raised on your arm creates a greatest surface area which traps heat. Another, your intestines. Their primary role is to take in nutrients from your digestive tract, across a surface, into your bloodstream. Your intestines are folded into columns called villi, which have further folds in them called microvilli. And why is this necessary? The greater the folds, the more surface area, meaning more efficient nutrient absorption in the gut. Some estimates have the amount of surface area in the small intestine alone equal to half of a tennis court. To recap, why are there no elephant-sized amoebas? As cells get larger, their volume increases at a faster rate than their surface area. A supersized amoeba would either starve or be poisoned by one of its waste products. This is not a pretty picture. Today's question of the day is about calculations. Which has a greater surface area to volume ratio? A spherical cell with a radius of 40 micrometers or 20 micrometers? For the answer to today's and future questions, please follow us on Instagram at TheApsoluteRecap. That's the APsolute RecAP. If you are a student with questions or a teacher with suggestions, we'd love to hear from you. If you have a biology topic or another AP subject you would like us to cover on The Absolute Recap, please email us at TheApsoluteRecap@gmail.com. That's the APsolute recap@gmail.com. The Absolute Recap is produced by Brad Kingett with music by Zach Caruso. Please remember to rate, review, and subscribe wherever you get podcasts. Time's up, pencils down. Thank you for listening to the Absolute Recap Biology Edition. AP is a registered trademark of the College Board. Copyright 2020, Absolute Recap, LLC, all rights reserved. Coming up next on the Absolute Recap Biology Edition, Episode 8, covering Unit 2, Cell Structure and Function.